Hi everyone. Welcome to my secret location. Anyway, today we're going to start this topic. Okay, this subtopic, which is composite functions. Okay, so for those of you who are new, welcome to 4S2 and welcome to Advance with me. Wow. Okay, but right now we're in 1.2 already. Okay, you just missed 1.1, and so I hope that those of you who are new, please catch up on what you didn't know on 1.1. Ask your friends. I think there are previously 5 videos that I shared that I think you can also use now. But anyway, we're going to go to 1.2, okay, which is talking about composite functions. Composite functions happen, okay, when you have two functions. Okay, you have two functions, one after another. So you want to know how it is mapped out, okay, in this situation. So let's say, for example, you have the original objects are all here, okay, and then because of one function, the function g, okay, you map it out into this one lah. And then we use this result and you map out another function, okay, which is, let's say, for example, is y plus 2. So then we get this end result. So what we are actually doing, since there's a double mapping, so we consider this as a composite function. We combine both the functions together, because if you see, the original function g is x squared. And then the second function, which is, f, okay, is the object plus 2 lah. Okay, in this case, I'm going to call this object y, so that we don't confuse. The original object is x. Okay, so after the first function, we square the object, then the already squared object, then we put it in another function lah. Okay, so we get y plus 2. So the idea behind this is, how do I get from the original this one to this one? Okay, so we call this a composite function. And the way we do the composite function is, we start from the end. Okay, the end is this one. Okay, then we work our way backwards. So since our n is 3 and 6 over here, so the second function that we do is f. Okay, then the first function that we do is g, and then we put in the object. So this is what we call a composite function. Okay, where by writing it like this, I know it's a little bit weird because the second function is first and then the first function is second. Okay, but you have to think about it in terms of the object. Okay, the original object is this x. And so the first function that we use the object on is g. And then the second function is f. Okay, now I know it sounds very complicated, okay, but I think these two diagrams are quite helpful for you to see it. Okay, so if we're going from the original to the end over here, we call this fg, because the first function that we do is g, and then only the second function is f. So we write it as fg. Okay, so we can also write the composite function like this, or we can split it up. We put the first function into a different bracket so that we tell ourselves, oh, okay, let's do this function first. Okay, this is the first, and then this is the second. Okay, so the combination of both functions will look something like this. Okay, so as you can see, this fgx, the gx over here is x squared because the original g function is x squared. Okay, so we put the x squared over here, and then we put it into the function y plus 2. Okay, so then we have x squared plus 2. But I think the most important part, okay, of this is to understand how this function works. Okay, think of it in terms of the mapping. I always find that when we look at the mapping, it actually helps us a lot. So let's begin. Okay, so for those of you who are new, okay, I always do this because at the very beginning, you don't have your workbooks yet, so I cannot really do much, so I'm dependent on the work on the textbook now. So what I want you to do, if you haven't done this, please copy down these questions into your exercise book first. Okay, and then after that, you can pause the video now, you copy down these questions into the textbook, leave some space for your answers, and then after that, you play this video and you write down the answer as I'm teaching it. Okay, so I'm going to use these questions to teach you how to understand this particular part properly. So each self-practice over here is one video by itself. Okay, and I hope I hope to be able to finish all these videos for this chapter 1 as soon as possible lah. Okay, it's going to take me some time, but yeah, just be patient with me. Okay, so in the arrow diagram to the right, function f maps set P to set Q, and function G, okay, maps set Q to set R. Okay, so determine function f. Okay, if the original one is x, and after you do the function, it becomes 3x. So therefore, and this one we've already done in subtopic 1.1, the function of fx is 3x. Okay, because the function, the original object is x, and then the end result is 3x. Okay, so what about the second question? The second question says that GF. Okay, now GF, let me write this properly. GF, and then I'm going to put the original object lah. Okay, now as I said just now, this is the first function that we do. Yeah, this is the first function that we do, and then this is the second function, the pink color one. This is the second function. The first function is this because it maps from the original object to this one. And then after that, the second function is G. So actually, GFX, okay, this is very simple actually. GFX equals to 2x minus 7. Okay, simply to understand this, that after both functions, this is the end result. Okay, the first function is f, so you map from x to 3x. The second function is g. You map from 3x to 2x minus 7. You combine both gfx, okay, is how you get from x, okay, then you push through the two functions, and then last you get 2x minus 7. Okay, now at this point, I know sorry, I can understand if it's very abstract, like apa bahasa cakap ni kan? Okay, I know it seems very abstract, okay, but I think it's important for us to really work this through. Okay, it's not going to be, sometimes you won't get it on the first try, and it's fine. Okay, it's fine if you don't get it on the first try. You can rewatch this again and listen to me bebel pasal the first function, the second function, and then but the most important thing is that you need to understand, okay, that the first function that we work on first is always the one that is nearest to the object. Okay, then after that, we work the outside function. Okay, I used to call this, and I think there will come a point in time where I'll talk about this lah. This is what I call the inside function, means the one that is nearest to the object. And then this one is the outside function. Okay, I will talk about this one in a little while, the inside-outside function. Okay, but right now, the first function, which is the nearest to the object, okay, this is the original object, right, x. The first function is the inside function, and then the second function, which is a little bit further, is the outside function. The first function maps the object to the first image. Okay, and then the second function maps the first image to the final image, the second image. Okay, so when we combine both together, GFX, okay, maps the object all the way to the second image. This is the big picture, okay, that we need to talk about. Okay, everything after this is all mathematics. This concept is very important. Okay, which is why you see me spending a lot of time talking about this question, and I feel like at some point, okay, like I'm just babbling on about the same thing, but it's a concept thing. Okay, it's a concept thing that will take us some time to go through. It's okay, it will take us some time to understand, but we need to understand this, okay, in order for us to be able to answer this. Okay, so for each of the pair of functions below, obtain an expression in the form of there's fg, there's gf, there's f squared, and there's g squared. So there's actually 4 things you need to do. You need to find 4 functions. Okay, so let's go through this together. The first one is fx equals to 3x. Sorry, I'm going to rewrite it in our normal way. Okay, and our second one is gx is 3 minus x. Okay, gx is 3 minus x. So the first question is fgx. Then fg, gf, f squared, g squared. Okay, so let's start with fgx. Okay, and let me write it in different colors so it's easier for you to see. Okay, I'm going to put gx as purple. Okay, so the first thing you do is take the gx and put it next to the f. Okay, so you will get f, okay, and then what is your gx? Your gx is 3 minus x. Okay, so after that, we need to remember, okay, everybody, this is the object, okay, in this function. The object, whatever that is inside the bracket, must be put into the object, okay, that is on the other side of the equation. So now our object is 3 minus x. Therefore, okay, therefore, this will become 3, okay, times 3 minus x. Okay, our object, this is our object. Okay, 3 times 3 minus x. Okay, I think if I were to write it in one line, it may look easier for us. Okay, f3 minus x equals to 3 minus x. Can you see how it looks like now? Okay, see the object is here. This is the object. Okay, compare this one and this one. That's what I'm doing. Okay, I'm taking whatever the object is inside the bracket, I'm putting it into the equation. Okay, even if the object is like, Marcus owns a boat. So it's fine, 3 times Marcus owns a boat. Fine, whatever. Okay, after this is a very easy solve. You can solve this equation already. 3 times 3 minus x will give you 9 minus 3x. Okay, and that's your function. Okay, so what does this mean? Okay, so what does this mean is, if I map it out, okay, I'm only going to do this once. I'm not going to do this every equation. Okay, I'm going to only do this once. Okay, so the first mapping is G. Okay, the first mapping is Gx. The second mapping is Fx. Okay, so the whole thing is Fgx lah. So if our original one is x, okay, the x will map out to be apa? 3 minus x under G bahkan. Okay, the x will map out to become 3 minus x. Then the 3 minus x under the fx, okay, will be 9 minus 3x. This is what it means. Therefore, under the entire thing, if I shortcut this from here to here, under fgx, okay, I will get 9 minus 3x. Okay, I cannot stress enough that if you understand this, how the mapping works, this chapter will be super, super, super easy. Okay, the biggest danger is for you to jump into the exercise without understanding what is happening in the mapping. Okay, because as the equations become more and more complicated, it's going to become more difficult for you to understand. But you understand how this mapping works, trust me. Okay, this chapter will be very, very easy. But please take some time. If you don't understand what I just said, go and rewind back and understand how this mapping works. Okay, the object becomes the image, and then the image becomes the object to become the second image. Sorry, I think I better stop talking. The more I talk, the more worse it seems to be. Okay, so question B. Question B is GFX. Okay, I'm going to write this differently. Okay, GFX. So let's put the fx in first. Okay, so this will be G. What is our fx? Our fx is 3x. Okay, so this will be 3x. Okay, so let me compare this. Okay, gx, dia cakap tadi, gx equals to 3 minus x. Okay, if this is the object, okay, but now we have a new object. Our object is 3x. So when we write it, it will be 3 minus 3x. You see what I'm doing there? Okay, I'm substituting the new object into where the object is supposed to be. Okay, therefore, I will get this answer, 3 minus 3x. Okay, I know I'll say that I know I said I'm going to do it one time, but let me do it one more time now, okay, just in case it helps you. Okay, the first function that we map is f, okay, because it's the inside function. Okay, so the first function is f, from here to here, fx. Our original is x, and then it becomes 3x. Okay, the second function we map, okay, is from 3x to become 3 minus 3x. This is gx. Okay, so when we combine both, jumping from the original, the first object to the second image, you will get G, F, X. This is what it means. When we run the X under two functions, first F and then G, we call this GFX. Why is it terbalik? Because there's an inside-outside thing, but the end result we get is 3 minus 3X. Okay, from these two examples, you will notice that FG and GF is different because the mapping is different. Okay, so dia bukan F darab G or G darab F. It's not multiply. Okay, it's go from F to G. Sorry, in the first function is go from G and then F. Okay, but the second function is go from F and then G. Okay, so the mapping will be different. So you won't always get, actually it's not always like you will get the same answer, but you need to understand that both functions are different. FG does not always equal to GF, okay, as shown in this case. Okay, let's go question C. Question C says F squared. Okay, now what F squared means, I'm going to add the X over here. What F squared means is Fx. That means I double the F. Okay, let me rub this off. Let me change this to purple color. So this will be Fx. Okay, so what's our original Fx? Our original Fx is 3x. Okay, so I'm going to write this as F. Okay, then change to purple, 3x. Okay, let me write it again now. So Fx equals to 3x. Okay, now I have F3x. Okay, my object has become 3x already. Okay, so my image will be, keep the original 3, but now my object is 3x. Okay, so this will give me 9x. Okay, in terms of the mapping, I keep saying that I won't do this, but I do this anyway. Okay, x. Okay, after the first mapping, fx, it becomes 3x. Okay, and then you map another time. Okay, under the same mapping, you will get 9x. Okay, why? Because this object is now 3x. So 3 times 3x will give you 9x under the second mapping. Okay, so this is Fx. Okay, finally, D is G squared. Okay, and G squared just simply means GGX lah. Wow, GG. Okay, so GX will give you G, change color, GX. What's my original GX? My original GX is, where is it? 3 minus X. Okay, so G, okay, 3 minus X. Sorry, let me change this to purple. Okay, 3 minus X. Okay, now my object has now become 3 minus X, but my function is still the same, 3 minus X also. Okay, so this will give me 3 minus, then I put my object in, which is 3 minus X. Okay, this will give me 3 minus 3 plus X, which will just give you X. Okay, I am not going to spend time explaining to you why this has become plus. I hope you know this at this point. You should know this at this point. Okay, so this is the first question. All 4 equations are solved. Okay, next, question B. B is 4 plus 2x and x squared. Okay, so fx is 4 plus 2x, gx is ex squared. Okay, I'm going to quickly go through this. So the first one is fgx. I think so. Yeah. Okay, fgx. I'm going to put f. I'm going to substitute in gx first, x squared. Okay, and then take a look. My object has become x squared now, but the original one is x and x. So I'm going to put this into the equation. 4 plus 2, and then my object has become x squared. Okay, so this will give me the answer 4 plus 2x squared. This is this one. Okay, gfx. Okay, let's put the f in again. So g What's my f? F is 4 plus 2x. Okay, take a look at the g function. The g function is x squared. Okay, the object squared. Now my object is 4 plus 2x. So if object squared means what's going to happen is the 4 plus 2x is going to become squared, like that. Okay, so the function of g is the object because it's squared. The function of f is 4 plus 2 times the object. Okay, this one, please expand this. Don't leave the answer as it is like that. So this will be 16 plus 16x plus 4x squared. Okay, you can leave the answer as such. Next, fx, okay, which is f squared lah. Okay, ffx. So f, what's my f? Okay, my f is 4 plus 2x. So I'm going to put this object into the f. Okay, what is the object of f? X first, right? Okay, so it's 4 plus 2 object. So now my object is 4 plus 2x. Okay, so I'm going to use this and put it into the function. So this will be 4 plus 2, and then I'm going to put the object 4 plus 2x. Okay, so the yeah, I know this is very fast, but it takes some getting used to, which is why, okay, I like the semangatness of this class. I hope you don't lose the enthusiasm. Okay, every morning start your mornings by doing maths. Okay, trust me, in the long run, you will be better for it. Okay, so 4 plus 8 plus 4x. Okay, let's solve this. This would be 12 plus 4x. Okay, simple. Well, simple lah. Okay, g squared with gx makan. Okay, let's put the gx in. Okay, what is gx? Gx is x squared. X squared. Okay, let's put this object into the g function again. Okay, so the object is x squared. The whole thing you square it. Okay, because it's object squared. Whatever the object is, you square it. Okay, so x squared squared, x squared squared will be x to the power of 4. Okay, that's the second one. The third one is x plus 4 and 6 over x. Okay, fx equals to x plus 4, gx equals to 6 over x. Okay, no sweat. Just remember, this is the object, this is the object. Okay, this is the object, this is the object. Okay, so whatever the object is, the object goes into the function. That's the important thing. Whatever the object is, the object goes into the function. Okay, so the first one is fgx. Okay, which means that our gx is the object. Let's put gx in. Okay, f 6 over x. Actually, you know what? Let me change color. Because it's object, okay, 6 over x. Now, as I said before, whatever our object is, in this case, the purple color one, we put it into the function. Okay, so this will be 6 over x plus 4. Okay, and if you remember from our first class, this one you have to qualify this because there's an x at the bottom. This will be x cannot be equal to 0. Okay, I'm going to leave the answer as such. Secondly, gfx. Okay, our object now is fx. So let's keep the g. Let's put in our object. Our object is x plus 4. Okay, so once again, this is the object. Okay, so let's put the object into the function. So this will give you 6 over x plus 4. Okay, end of story. You cannot continue anymore from there. Okay, so we just leave it as it is. Okay, let's go to fx. Okay, I hope by now you know that f squared is ffx lah. Okay, so let's put the object first. Okay, remember this is the object. So let's put fx in first. We will get f x plus 4. Okay, now this is our object. X plus 4 is our object. Remember, we put our object into the function. Therefore, this will be x plus 4. Let me highlight this. This is our object. Okay, then we plus 4 again because the original equation is object plus 4. Our object now is x plus 4, therefore object plus 4 will be x plus 4 plus 4, which will give you x plus 8. Done. Okay, here comes the complicated one, which is the g squared, okay, ggx. Okay, our first step is always the same. Put in the object first. Okay, so our object is gx, so we will get g 6 over x. Okay, now I'm going to change color once again. This is our object now. Okay, our object is 6 over x. The function of g is 6 over object. Okay, therefore, what you will get is 6 over, what's our object? 6 over x. Okay, this is our object. Okay, this looks very weird. We need to solve this. Okay, so when you solve this, what you will get, sorry. Okay, in case you don't know, 6 over x, okay, is 6 divided by 6 over x. Okay, it's the same thing lah. Okay, I shouldn't be explaining this to you, but in case you don't know, we should take note of this lah. Therefore, because there's a fraction and a divide, you switch it over. So it's 6 times x over 6. This will cut itself out and you will get x. Okay, that's our answer for this. Okay, finally, the fourth one. Okay, fx is x minus 5 and gx is 1 over x minus 1. Oh no. Okay, fx is x minus 5, gx is 1 over x minus 1. Okay, now no matter how complicated, okay, no matter how complicated the equation is, and it's going to get complicated, okay, always bear in mind what is the object of each function. Okay, this is the object of each function. So whatever the object is, if the object changes, it will also change in the function. Okay, so first of all, f gx. Now, gx is our object because it's on the inside. Okay, let's substitute gx in. So this will give you f. Okay, what is gx? Gx is 1 over x minus 1. Okay, as I said before, whatever is the object, we put it inside the equation. Therefore, this will give you 1 over x minus 1 minus 5. Okay. Unfortunately, you can't leave the answer as this. You have to simplify it. Okay. And when you simplify it, you will get x minus, sorry. Okay. I'm going to show you the simplification now. Okay. 1 minus 5 times x minus 1 over x minus 1. To give you 1 minus 5x plus 1. Sorry, plus 5. Okay, over x minus 1. So this will give you negative 5x plus 6 over x minus 1. X cannot be equal to 1. Okay. This is slightly more complicated, I know, okay, but just to let you know that these few steps, okay, actually is from 3 mathematics, okay, the simplification of fractions, algebraic fractions, okay, which you need to already be a master of. I really, really hope that you're a master at this point. If not, please practice, okay. Secondly, gfx. Okay, same thing. Substitute the fx into the g first. Okay, let's put it as a different color. Fx is x minus 5. Okay, so whatever the object is, okay, whatever the object is, put it into the equation. So you will get 1 over x minus 5 minus 1. Okay, our object is now this. Okay, look at the highlights in green. So after that, you will get 1 over x minus 6. Okay, because minus 5 minus 1 is minus 6 lah. Therefore, you need to qualify this. X cannot be the same as 6. Okay, in case you're asking, apa benda ini? Okay, if you don't know why I have to put this sentence over there, I think refer back to another example that I gave in the previous videos. Okay, or you can ask any of your friends. Okay, I hope the people who are originally in S2, you know, you can explain this to your friends. Okay, let's go to the other one, f(f)(x). Okay, f(f)(x). So first thing is, let's substitute the object. Okay, so this is f. What is f(x)? X minus 5. Okay, x minus 5. Okay, this is our object. So our equation, our function is object minus 5. Okay, our object is now x minus 5. So let's put in the object x minus 5. Okay, and then the equation is minus 5. Object minus 5. Okay, so minus 5 we give you x minus 10. Okay, this will be this one lah. And finally, ggx. You know what? I'm going to need a lot more space for ggx. Okay, ggx. Okay, once again, this is the object. Let's put in the object first. So g, okay, our object is 1 over x minus 1. 1 over x minus 1. Okay, this is our object. The g function is 1 over object minus 1. So now our object becomes like this complicated monster lah, okay? No worries. Okay, let's see how it goes. Sorry. 1 over, okay, what's our object? Our object is 1 over x minus 1. So 1 over x minus 1 minus 1. That's how this plays out. Okay, now, should I show this to you? Yeah, I think I should, but I'm running out of time. But okay, fine. Okay, fine. Let me show this to you. Okay. First of all, I'm going to dissect this. I'm going to make this. I want to just take a look at the bottom part first. Okay, 1 over x minus 1, the whole thing minus 1. So, okay, 1 over x minus 1 minus 1, the bottom part. I just want to see the bottom part only. Okay, so when I simplify this, I will cross multiply 1 minus 1 times x minus 1 over x minus 1. Okay, I'm making the fraction the same yang di bawah lah. Okay, so this will give me 1 minus x plus 1. Okay, over x minus 1. This will give me 2 minus x over x minus 1. Okay, so when I put this inside here, this will be 1 over 2 minus x over x minus 1. 2 minus x over x minus 1. Okay, and if you know your mathematics, the 1 over this one is just flipping the other way around lah. So our answer will be x minus 1 over 2 minus x. Okay, and this one we have to qualify also. X cannot be the same as 2. Okay, otherwise this equation won't function. Okay, so that's all. So far, that's it lah. Okay, for question 2. Let's move on to question 3 lah. So two functions, f and g, are defined by so and so. So find the expressions for fg and gf, and then find the values of x when f equals to g and fg equals to gf. So let's do this one by one lah. First of all, let's find the composite functions first, fg and then gf. Okay, so we're going to have fx equals to 3x plus 4. Okay, and then after that, gx equals to x squared plus 6. Okay, so just to remind you once again, okay, that whatever that goes into the bracket must always appear as the object. Okay, no matter what happens. Same thing goes for this lah. Whatever that goes into the bracket must always appear as the object. Okay, there's a reason why I highlight this. No, it's not for fun. Okay, so let's find fg first. I'm going to write it in different colors. fgx. So the first thing we do is substitute gx into the f function. So we will get f, and then what is gx? Gx is x squared plus 6. Okay, so going to highlight green again. This is now our object. Okay, so if our object has changed to x squared plus 6, in the function itself, that object must change accordingly. So it will be 3. What's our object? X squared plus 6 plus 4. Okay, our object goes in here. And then after this, simplify this equation. So 3x squared plus 18 plus 4 will give you 3x squared plus 22. Okay, end of story. Next thing, same thing, g, but now we put fx. Okay, so the first thing we do is substitute the function first class, since this is the, remember, this is the inside function. Okay, the inside function is an object. So we put the function in first. Okay, so this will give us g, and then our fx is 3x plus 4. Okay, and so I used the wrong color. Okay, fine. Okay, same thing. Now our object has changed to 3x plus 4 for the function of g. So when we write it out, it has to be 3x plus 4, the whole thing squared plus 6. Okay, that's basically what I'm doing, putting the object into the function. Then simplify this. After this is all mathematics from 3. So simplify this, you will get 9x squared plus 24x plus 16 plus 6. Okay, and this will give you 9x squared plus 24x plus 22. That will be your answer lah. Okay, so now the next question says, find the values of x, okay, when AF equals to G. Okay, so let's start with this one first. So if F equals to G, therefore 3x plus 4 equals to x squared plus 6. Okay, and then this will bring us to, find the values of x. We have to solve the equation lah. So let me move everything over here. 0 equals to x squared plus 6 minus 3x minus 4. Okay, let me simplify this a little bit. 0 equals to x squared minus 3x. 6 minus 4 will give you plus 2. Okay, so this one, I hope that you remember this from Form 3. Okay, if not, then, we will take some time to do this. But 0 equals to x minus 2, and this will be x minus 1. Okay, and this will give you x equals to 2 and x equals to 1. Our two answers over here. Okay, in case you're not familiar, this step is called factorization. Okay, so the factorization step is something that you have actually learned in lower form. Okay, so it's a skill that we will always use actually in maths. Okay, the second one is FG equals to GF. So just now we found FG and we found GF. Now we're going to equate them. Okay, so you know what? Let me write this a bit nicer. Okay, so FG equals to GF. So 3x squared plus 22 equals to 9x squared plus 24x plus 22. Okay, so we're gonna do this like this lah. So I think to make things simple, I'm gonna move this side since the 9 is a bigger number here. So 0 equals to 9x squared minus 3x squared. Okay, I'm putting all the similar ones together. Plus 24x plus 22 minus 22. Okay, so this will become 0. Okay, so we don't need this. Hold on, let me just double check something. Yeah. Okay, and so we're left with 0 equals to 6x squared plus 24x. Okay, and so when we factorize this out, we'll get 6x. This will become x plus 4. So there are two values here again lah. Okay, x equals to 0 and x equals to minus 4. Okay, these will be both our answers for this. Okay, finally, not finally, number 4. Okay, given that fx equals to ax plus b and ffx is 4x minus 9, find the value of constants a and b. Okay, so let's write this first. Fx is ax plus b. Okay, and then ffx, because we already established that f squared is ffx. Okay, so the double function will give us 4x minus 9. Okay, so the question is, what is A and B? Okay, so let's begin with this. Okay, now we know that FFX, if we're going to use double FX for this, okay, FFX. Okay, so the first thing we do is, actually, you know what, let me change color. The first thing we do is we put the function into the composite function. So this will give us the F over here, and then this will be AX plus B. Okay, so reminding you again, whatever that is the object, okay, needs to be the object in the next function. Just so happens that our function is also F. Okay, so we're going to put AX plus B into the place of the object. So, so this will give us A, and then after that, oh, you know what? Let me change color, sorry. Okay, we're going to get A, okay, what is our object now? Our object is AX plus B. So AX plus B. Okay, and then I'm going to finish this like that. Okay, then after that, simplification. Okay, A squared X plus AB plus B. Okay, so now you have on one hand, okay, an FFX that is fully A and B, and on the other hand, you have already the finished FX, sorry, the finished FFX. So since both are FFX, we can say that A squared X plus AB plus B equals to 4X minus 9. Okay. Now, if you look at this, okay, you can conclude two things. Number one, there is only one number or one thing that is with the X. Okay, and then the rest of it got no X. So you can actually say that the blue color, sorry, this pink color is the same thing. And then this green color is the same thing. Okay, this is what we do. What we're doing is we are comparing the left and the right side. Okay, when we compare the left and the right side, then we can conclude that A squared equals to 4. Okay, and AB plus B equals to negative 9. Okay, now let's begin with the left side. If A squared equals to 4, then we're going to have two answers. Okay, A is 2n minus 2. Okay, because square root of 4, when you want to find A, you have the square root. Square root of 4 will always give you two numbers. One is positive, one is negative. Okay, so then we have to find two sets of answers for B. Okay, so when A equals to 2, okay, then you're going to get 2B plus B equals to negative 9. 3B equals to negative 9. So B equals to negative 3. This is one set. You have to consider the second possibility that A equals to negative 2 because there are two answers for A. So if there are two answers for A, there must be two answers for B. So when A equals to negative 2, so you substitute properly lah. Negative 2B plus B equals to negative 9. Negative 2B plus B is negative B equals to negative 9. So B equals to 9. Okay, so you get two answers for A and two answers for B. Okay, again, everybody, the only part that is actually at maths okay, the only part that is actually at maths is this part. The one that I write this, the braces, okay, the bracket there, that's the only part that's actually at maths. Everything else, okay, that is on the right side is normal mathematics. Mathematics that you will learn that you have already learned in Form 1, Form 2, Form 3, and also that you're about to learn in Form 4. Okay, so a lot of people say that admaths is very difficult, etc., etc. Actually, the thing that makes admaths very difficult is if your basic maths is not strong enough. Okay, I'm not saying that your basic maths is not strong enough, but if you are struggling with this, then it can mean two things. Number one, you really don't understand what's going on. And number two, your basic maths is not strong enough. And I hope that is the second one, because if your basic maths is not strong enough, means it can get stronger. Okay, all you have to do is just keep practicing. Okay, sorry. Last question. If fx equals to 3x plus k, gx is this, and then fg equals to gf, find the relation between h and k. Okay, let's begin. So fx is 3x plus k, gx is 2h minus 3x. Okay, 2h minus 3x. Okay, now, and then this says that fg equals to gf. Okay, sure, no worries. Let's start with fg first. So I'm going to put gx over here. The first thing we do is substitute the g, okay, because that's the inside function. So the inside function, we put it in, we're going to get 2h minus 3x. Okay, now I'm going to, highlight this green color. Okay, now our object is 2h minus 3x. We're going to put it into the f function. Therefore, we will get 3. And what is our object now? Our object is 2h minus 3x. Okay, and then we're going to finish up the function plus k. Okay, that's basically what we're doing. Okay, let's simplify this. We're going to get 6h minus 9x plus k. Okay, we're going to leave it there first. Let's go to the other one, which is gfx. Okay, gfx. So once again, ask yourself, what is the function that is on the inside? The inside function is fx. So this will be g, and what is my fx function? Well, my fx function is 3x plus k. Okay, purple color. This is the object. Okay, the whole thing is the object. 3x plus k is the object. So when you put it in, you're going to get 2h minus 3, and then I put my object in 3x plus k. Okay, we simplify this. Simplify this, you get 2h minus 9x minus 3k. Okay, and then we're going to leave it there. Okay, now we are going into this. It says that fg equals to gf. So this left-hand side and this right-hand side must be the same lah. Okay, that's what's given in the question. So 6h minus 9x plus k equals to 2h minus 9x minus 3k. Okay, the first thing you're going to notice is that the x's will disappear because both of this is the exact same thing, minus 9x minus 9x. Okay, so since they're the same on both sides, we can eliminate them. It will become 0 lah. So you're left with 6h plus k equals to 2h minus 3k. Okay, now let me group everything together. I put the h on the left and the k on the right. So 6h minus 2h equals to negative 3k minus k, which will get 4h equals to negative 4k. Let's go back to the question now. The question says, find the relation between h and k. So if you want to say the relation between h and k, what you can do is either h equals to yada yada or k equals to yada yada. Either way also doesn't matter. Now let's say I take option 1 lah. I take this option. I'm going to put the h as the kepala rumus. So I'm going to move the 4 over. Okay, so h equals to negative 4k over 4, which will give you h equals to negative k. Even if I do it the other way around, let's say I want the k, okay, I don't want the h. Okay, sure. If I want the k, then I'm going to move the negative 4 across. So k equals to 4h divided by negative 4, which will give you k equals to negative h. Okay, k equals to negative h. Either one of these answers, okay, is correct. Either one is fine. Find the relation between h and k. Okay, but that would be the answer to this question lah. Okay, now I know that doing composite functions usually is the number one challenge lah, okay, for a lot of students. This is only the first part. Okay, but as I said, okay, give yourself time, don't rush through the video. The most important thing is that you don't rush through the video. Finish it, okay? Take your time, okay, if you can, but keep working at it, okay? Don't give up. I always believe that people can do admits one, they just have to spend time doing it, okay? And I think among all the subjects, you really need to spend the most time with this, okay? Because it's a very important subject, lah. Okay, so I'll see you at the next video.